Hello and welcome to Brain Bites. Today's topic is directly connected to your health, lifestyle, and everyday choices. We're talking about the beating heart of the modern economy, the trillion-dollar global semiconductor industry. I mean, this is a space that brings together literally the most brilliant scientific minds on the planet to push the absolute boundaries of hardware, software, chemistry, and physics. And right now, well, it's being pushed to its absolute physical limits.
Just think about this number for a second. $30,000. That's what just one of today's most advanced, high-end chips can actually sell for on the open market. We're talking about a single, incredibly delicate piece of silicon that's packed with components literally smaller than a virus.
And because they're so insanely lucrative, and honestly so fiercely critical to our entire global infrastructure, they're reportedly being transported in armored vehicles. It sounds like something out of an action movie, right? But without these tiny, super fragile components, nothing works. Not your smartphone, definitely not your car, and for sure not the massive data centers that keep the modern internet running.
Okay, let's dive into this. Someone once said, making a chip is like building a house of cards, with thousands of people located on multiple continents. And honestly, that is a brilliant metaphor. It captures the terrifying reality of this global supply chain perfectly. Every single card has to be delicately balanced at the exact right moment. If just one card is misplaced, or if there's a disruption in some far-off corner of the world, the entire global supply chain could just topple right down.
And the stakes? They seriously couldn't be any higher. A recent Bloomberg economics report actually estimated that if the Taiwanese chip ecosystem were to collapse, it could trigger a catastrophic $10 trillion loss to the global economy. $10 trillion. That is just a staggering amount of financial risk concentrated in one specific industry.
So, to understand how we got here, we're going to take a logical journey across this hyper-concentrated supply chain. We'll look at the AI catalyst, the most complex machines, the Taiwan bottleneck, a geopolitical standoff, and finally, reshoring the supply chain.
Let's start with part 1, the AI catalyst. And this brilliantly illustrates exactly what's shifting right now. For years, semiconductor manufacturing was kind of this obscure backwater of the tech world. But today, the demand for AI infrastructure is just massive and totally insatiable. AI chips accounted for more than a quarter of all chips sold in 2025, and by 2029, that figure is projected to surge to half of all global sales. Spending on AI data centers is on track to cross the $1 trillion mark soon. This isn't just about upgrading a PC anymore. We are in a sustained super cycle of growth.
Moving on to part 2, the most complex machines.
So, to meet that soaring demand, we have to rely on literally the most complex machines ever engineered by humans. Nestled among the windmills of the Netherlands is a company called ASML. They are essentially the gatekeepers to the physical limits of chip manufacturing. They're famous for perfecting a process called lithography. Basically, it's this hyper-specialized process of directing light through a series of mirrors, lenses, and a blueprint to transfer invisible electrical pathways right onto silicon wafers. They are shrinking chip designs down to sizes that are 50,000 times smaller than a single human hair. The contrast here is just mind-blowing. To create these microscopic components, again, literally the size of a virus, ASML had to build these massive extreme ultraviolet or EUV machines. These systems are as big as a double-decker bus, they weigh as much as a blue whale, and they cost customers around $400 million for a single machine. And get this, ASML is the only company on Earth that makes them.
These colossal machines are used to print transistors. You can think of transistors as nanoscopic light switches that generate the ones and zeros of all digital data. Companies like AMD actually design these incredibly advanced architectures to run everything from the world's fastest supercomputers to massive AI servers. If you're finding this video useful so far, take a second to like the video. It really helps the channel grow and reach more people.
Which brings us to part 3, the Taiwan bottleneck.
Okay, so we have the design and we have the machinery. Now we need the actual logistical choreography to build the things. Think back to that house of cards metaphor, right? Step 1, the majority of the chip design happens over in the US. Step 2, the machinery comes from the Netherlands and raw materials come from places like Japan. But then, step 3, all of this global innovation is funneled across continents into fabrication facilities or fabs that are located almost entirely in one tiny geographic location, Taiwan.
Now, what's really interesting about this slide is just how incredibly narrow that funnel gets. Taiwan Semiconductor Manufacturing Company, better known as TSMC, manufactures over 90% of the world's most advanced chips out of their massive gigafabs. 90%. It is the absolute bottleneck of bottlenecks for the entire global tech ecosystem.
That takes us to part 4, a geopolitical standoff.
Having 90% of the world's advanced computing power manufactured on one single island obviously exposes the global supply chain to some pretty severe risks. Because of this terrifying fragility, global superpowers are currently racing for technical supremacy, and they are spending heavily to do it. On one side, the United States rolled out the $52 billion CHIPS Act to incentivize domestic production. Meanwhile, the Chinese government launched a $50 billion chip fund to develop their own homegrown manufacturing base.
So, the crucial takeaway here is that this industry is being squeezed by multiple, massive pressures all at once. You have Taiwan's natural seismic activity threatening factories, you've got the lingering scars of those post-COVID global shortages, and you have tightening U.S. sanctions aimed at blocking the sale of ASML's advanced machinery to China. But the situation is constantly evolving. Chinese firms like Huawei recently shocked the industry by developing advanced chips in secret factories, proving just how rapidly domestic capabilities can evolve to skirt those exact sanctions.
And finally, part 5, reshoring the supply chain. All of this immense pressure has led governments and megacorporations into a massive financial scramble to rebuild this house of cards on a much more diversified foundation. The numbers really tell the story here. Back in 1990, nearly 40% of the world's chips were manufactured right in the United States. Fast forward to 2024, and that share plummeted to just 10%. To reverse this trend, the U.S. is heavily subsidizing new infrastructure. In fact, TSMC alone is committing $165 billion to build new gigafabs in the Silicon Desert of Arizona.
But building a stable foundation isn't just about those cutting-edge, super expensive AI processors. We also have to talk about analog chips. These are the basic, cheap, but absolutely essential components made by companies like Texas Instruments. While the advanced chips are busy running complex AI software, analog chips do all the fundamental grunt work. They sense temperature, they manage power, they keep the hardware from literally melting down. They are the essential nuts and bolts of the digital world.
Now, some of these analog chips cost mere cents to make, and they're about the size of a tiny pepper flake. But Texas Instruments is making a massive $60 billion bet on volume economics. They're upgrading their manufacturing lines from 200mm to 300mm wafers. Now, that might sound like a simple size upgrade, but a 300mm wafer holds 2.3 times the number of chips. That gives them an absolutely monumental competitive advantage when it comes to scale.
And to see where that scale really comes to life, look at the new mega site TI is building in Sherman, Texas. It's straight out of science fiction. It's going to be 100% automated, complete with 15 miles of overhead tracks, and it covers 5.5 million square feet. To put that into perspective, that's the size of 2 Empire State Buildings. Very soon, this single facility is going to churn out hundreds of millions of these essential chips every single day.
So, it all leaves us looking toward the future with a pretty provocative question. As the AI boom pushes technology to its absolute physical limits, is our global house of cards finally becoming a solid foundation? The trillions of dollars currently being invested certainly hope so. If you enjoyed this video, hit the like button, share it with others, and subscribe to Brain Bites for more valuable insights.